Welcome to In the Workshop, a Stuart 504 boiler part 10, more paint on the baseboard and making a check valve adapter. The couple of coats of grey primer from yesterday are now dry, so I'm currently sanding the baseboard with a piece of wet to dry sandpaper. It's only a light sanding, so I'm using it dry. And now it's back into the outer part of the workshop to give it another coat. First of all, as before, underneath first, but this time it's black paint. This is not the usual high quality paint that I use, it's just some stuff called High Coat, which is quite cheap really. I bought the Stuart 504 boiler via eBay in the first place because I wanted a simple and cheap workshop boiler. One that I could run inside the workshop without tripping the carbon monoxide alarm, and one that holds a lot of water for its size. A Stuart 504 boiler fits this description perfectly. While the first coat of black paint on the baseboard is drying, I've come into the inner part of the workshop where the smell of paint isn't as strong, but I'm only here to pick up the boiler and take it outside. As I remove the check valve, water runs out of the boiler because it's quite full. And this was taking ages, it just dribbled out of the boiler. So I picked up the boiler and blew into the tap, and this emptied the boiler much more quickly. This is a good time to pause the video while you go to the toilet. I did when I got to this bit in the edit. And now I'm going to be in the inner part of the workshop for a while. On the right of the image is the check valve, on the left is a piece of phosphor bronze which is 1/2 inch in diameter. I'm going to make a simple adapter, but I have to be careful that I don't make the adapter too long, because the 5/16 check valve needs to clear the water gauge. I started cutting the bar with my bandsaw, but the blade wandered all over the place. So instead of cutting it with the bandsaw, I put the piece of bar in the chuck and parted it off using a parting tool. This phosphor bronze is actually leaded bronze and it cuts beautifully. The next step is to change the cutting tool and face the end. This video clip is running in real time. Later on in the video though, I will be speeding up some of the operations just to get through it. Now I need to turn part of this down to 5/16 of an inch, and then I will thread it 5/16 by 32 threads per inch. This is the part of the adapter that will screw into the boiler bush. From experience I have a rough idea what 5/16 of an inch diameter looks like. And often, just to speed the job up, I will initially set the micrometer using a twist drill, and then check the vernier to get it to the exact dimension. In this clip I'm using my old file, and please note it is fitted with a handle to just take the sharp edges off the piece. Now I need to drill a hole in the middle, so the best way to do this, as always, is to use a centre drill, and that will ensure that the hole is in the centre of the work. The next part of the job is to thread the bar that I've turned down to 5/16 by 32 threads per inch. I'm doing this by hand, and I'm using a tailstock die holder, which of course is fitted with a 5/16 by 32 threads per inch die. The next part of the operation requires a hole to be drilled down the middle, and I'm using a 9/64 of an inch diameter drill, because if I use a drill that's too big the fitting will be weak, and if it's too small that would restrict the flow of the water into the boiler. In this clip I'm using my parting tool just to take a very tiny amount off the bar, just to clean it up and make it shine. And once I get to the correct position where I need to part off this piece, all I need to do is wind in the handle on the cross slide, and that will move the parting tool into the work and part it off from the main piece of bar. Like this in fact. This leaded bronze really does cut well, even though my parting tool is anything but at centre height. As I've kept sharpening it, it really needs lifting in the tool holder. You will see that when the part falls into the chip tray, how far under the centre height the parting tool really is. And watching the edit, it looks like the parting tool's a bit loose too. Note to self, always check that the centre height is correct before parting off any pieces of metal. The centre height needs to be like this, exactly on the centre height of the work. Looking at this though, this one is minutely under the centre height, but not as it would make any difference. I'm not after all making parts for gas turbines or satellites or spaceships. I'm making an adapter for a model steam engine boiler, so I have 2 check valves on the inlet. And in this clip I'm drilling a hole down the middle which is tapping size for 5/16 by 32 threads per inch. The tapping size for an ME thread 5/16 by 32 is 9/32 of an inch, And here in slow motion I'm threading the hole in the piece of metal. This is the part that I cut to length earlier, and it's still a little bit on the long side, so I'm reducing it a bit by just nibbling away at it like you see here. In this clip, as I was shortening the length of this piece of bar, it broke into the hole, which is just what I wanted anyway. All I have to do now is turn this part round in the chuck. Although for 100% accuracy you shouldn't do this, I must say this is not what you should do. But as I've just mentioned, this is not a precision part. Here are the basic components for the check valve adapter. What I need to do now is machine one of the parts to fit around the other one. And to do this, I've fitted the part in the machine vise on the milling machine, and I'm using a 1/2 inch diameter end mill to make this part of the fitting fit snugly over the other part. It's very important to make sure that the milling cutter is in the middle. There are two things wrong here: it's not in the middle, and also the small part is not perfectly horizontal. But using my fingers and my calibrated eye, I soon put that right. Now I can continue the operation, but I'm using the milling cutter like a drill. I'm not putting sideways pressure on it. I keep lifting it back to the top and winding the handle to lower it down. It puts less stress on the work, because don't forget that there isn't that much surface area on this small piece of phosphor bronze to hold it perfectly securely. And you really do need to have a delicate touch. The more machining you do, the better feel you get for the metal that you're cutting, and in no time at all, a check valve adapter in component form. Before silver soldering these parts together, there were two things I had to do. One was to check that everything was okay with the length of the centre barrel, and I cleaned up the edges of the other part using some emery cloth. Once again, it's into the outer part of the workshop, and this is my brazing hearth. It's made up of a double layer of vermiculite blocks. They're a bit of a funny colour because I do spray paint on this as well. But now it's silver soldering time. I've positioned part A on the top of part B in the correct position. I've applied some Easy Flow No. 2 silver solder flux between the two parts. Now all I need to do is heat it to the correct temperature and then touch on a stick of silver solder, which immediately flashes around the joint, and the job's done. Let it cool to black, quench it in water, and now it looks like this. The original idea was to fit two 5/16 fittings, and that would mean that by using union cone adapters I could reduce this to take 5/32 of an inch pipe, or 4mm pipe. But then, just like on the steam turret, where I had 3 available sizes, I decided to fit a 3/8 by 32 check valve on this side. This means that I have to thread the other side of the adapter 3/8 by 32 threads per inch. So I screwed this old piece of 5/16 of an inch diameter hexagon into one end, then I held the part tightly in the 3-jaw chuck, then drilled and threaded the end of it 3/8 by 32 threads per inch. And now it looks like this. Before I fit it all together though, there's one more job to do which is quite important. I definitely need to drill a waterway through the centre part. After that it's plain sailing. I can assemble the adapter. The 5/16 check valve will connect to the hand pump, and the other check valve can be quite simply connected to 1/4 of an inch diameter, 3/16 of an inch diameter and 5/32 or 4mm diameter pipe by just using simple adapters. After tying a piece of silicone rubber tubing to the part, it's time for the acid bath. And hopefully when I look at this tomorrow it will be nice and clean. And that's it for this episode. All I have to say is stay safe, stay well, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website. Click on the section of the website that says Video Playlists. And by doing that, you will find it very easy to find other videos that you may like to watch.